How's it going, folks? Today I'm going to do a little video on this invention that I created. I call it Vi Dynamics. In Hawaii we pronounce W's as V's, so it's Vi, and Vi is water dynamics. This is like a pitch that I was going to put, as an advertisement, just a little rough thing. This is all rough stuff. I was actually have a patent application filled out for it, but I just got so, fed up with the patent process and how much money it was going to cost me and everything. It was just turned out to be ridiculous. So I'm just doing a disclosure here, a public disclosure of it. If any of you guys want to build one of these, go ahead. I mean, if you want to mass produce them and sell them, go ahead. I don't have a fucking patent for it, so I can't afford it. So at least everybody will know that I invented this. Ryan Duggar invented this. At least as far as I know, and through my research. I got confidential non-disclosure agreements here signed by all kinds of people that I've showed it to. Engineers. This one guy, he's got 12 patents. I showed this to him. Got him to fill out one of these just to protect my own ass. Because I was really, I spent like a year on this thing. Just doing all this stuff. Here's the system itself. That's just like that's a rough drawing. That's all hand drawn. You got your water heater here. This would be set up as a preheat system for a regular electric water heater or a gas water heater. And what you got here is a bypass. It's a 4-way valve, and it'll send the cold water. It'll either send it up, or if you bypass it, it'll loop it back into the cold on this hot water heater. Otherwise, it makes it just open on both ends for direction. This direction this way, that direction this way. So open. Cold water comes into the house, and it goes up into the attic and goes into this tank. How do I have it piped here? This is the cold water. Okay, sorry about that, folks. This is the cold water coming in from your house that would normally go directly into the water heater. If you bypass it, it would bypass these loops and it would go directly into the cold water system. Alright, it comes up and it enters this manifold here. And I haven't figured out, my prototype isn't in-depth enough to, get into pressure balancing these loops, so everything would flow good. And that's if you wanted to run it as an active system, where you put a pump on it and stuff, so you make sure you get flow through all these loops evenly. But what they do is they run along the roof there. This is going to be the interior drywall, and you'd support them on each end. I got different ways. This is the first original one. I'm going to move to a different one, but you can see the gist of it. It's got a tank up there, a small, just a storage tank with a forced air to water heat exchanger. So it's got a passive air to water heat exchanger and a passive radiant surface. I can't think of the word right now, but yeah. Here's another. That's a closer drawing. This is all hand drawn again. Just, ideas on paper. That's the heat exchanger. You got that's a solar operated fan. Runs off a little, 12 volt DC solar panel. And it pushes the hot air from the attic. This is all up in the attic. So it sucks, because in Hawaii, your attic temperature can get up to 130 degrees. No problem. So it takes that hot air in your attic and blows it through this heat exchanger. And the cold water will fall out of this tank into that passively, no pumps, just because cold water is heavier, hot water is lighter. As it expands, it'll drop into here, and as it gets heated by that air, it'll rise back into the tank. And then the loops come down here, drop out of the tank. So when it's sitting here just static, this is what it's doing. It's circulating itself. The cold water is dropping down here, and as it gets heated, it gets sucked up, and it'll be cold down here, so it'll cool your ceiling surface. And then as it passes along, it'll get hotter and it'll start rising up, and this would be the ceiling, the roof surface, the inside of the roof in the attic. And that surface, that wood, on a hot day you go feel that wood, it's up 120, 115 degrees, and it'll get hotter and hotter, and it will rise into here. And it'll just keep doing that until it makes a whole storage tank, and it'll try to equalize with the temperature in the attic. So what you do is you passively cool your attic while you make hot water. It's pretty cool. There's another shot. That's the guts of the heat exchanger. My prototype doesn't have these. These would be like, you know, fin tubes from baseboard heaters. You could use that. That's what I had planned to do, but I live in Hawaii, so they aren't easily accessible. My prototype's all built out of, you know, recycled stuff that I had laying around. You got your panel. You got louvers on your side to evacuate the air. This is all hand-drawn stuff. Another hand-drawn one. This is getting into the heat plates that I got into after, you know, thinking about it. Just another hand-drawn one. Just messing around, thinking about it. Another hand-drawn one, top view. That would be looking down from the peak of your roof down on the system. I got, you know, started thinking about baffles to get that air piped from the very peak, the highest point. You want the hottest air at the highest point going through there. So, you know, just progressing along with drawings. And I got into, this is all computer generated stuff. This is just, all these are Microsoft Paint. Took me a long time to do this stuff. Not this one, this is just a fast one. Quick, easy, overall. Quick example, this would be in your attic. And this has got to be in places where it can't freeze, obviously. But now here's the real patent drawings that, and you may not want to believe me, but this is Microsoft Paint, people. Imagine how long that takes to do that. Numbered, everything. I have corresponding numbers in my patent application that you can reference when you're looking at this on the application, or reference the application onto the drawing. But you got a support system holding this tank as high in the attic as you can get it. That way you can use passive thermodynamics to make this sucker flow, and it will. I got one in my attic right now. It's just a prototype, but as you can see here are these heat plates that I started thinking about, and I think that would be the main patentable, you know, thing right there. I don't know though, because radiant floor heat, they probably have all this stuff covered, but nonetheless, I spent time on it. I want some credit for it if somebody starts selling these things, at least just so I know, people know. Not that it matters, but that would just be like an aluminum plate, you know, and have those would be cooling plates since you got cold water dropping, and obviously as it gets hotter it wouldn't be cold. But the thing about it is that since it's all passive, there's no external heat coming into this, so it can't heat your attic anymore. It's going to take the heat and try to store it in this tank. It's going to try to equalize throughout the whole system to the heat in the attic. So if you got a 120 degree attic, this puppy will get up to 120 degrees. If you got a 140 degree attic, it'll get up to 140 degrees, depending on how you have it sized. So that all comes into play with the, you know, designing of the system. But this is just, you know, the patent drawings. And that would be the exterior of the roof. I was getting a little bit more into these heat exchanger plates, whereas this might actually heat up your attic more. I don't know for sure, since you already have contact between your shingles and your roof surface. It's probably already radiating through, but what I have here is, this would be your plywood sheeting on your roof, and then these plates would have a flap on them that's soldered to them. Probably be on the lower side so that heat could rise, but this is just, you know, thinking about it. But these would come up and you'd have your boards, you'd have, you know, a board, you'd put them where the board butts, so that could come out, and then you fold it down, and this all goes underneath your roofing material. So when the sun's hitting your roof, it turns your whole roof into a solar hot water collector, and this will transfer the heat into these pipes that are running through them, and then it'll all get brought back to that tank and store it, and cold water will drop out, and it'll just keep doing that until it equalizes the pressure, or equalizes the temperature. And anytime you run hot water, it's gonna replenish the system with cold water, so then you're gonna get a cooling benefit out of it again. So, you know, you do a load of laundry on a steaming hot day, and you can feel it in the house, man. I'm telling you, it'll cool it. Not immediately, but anything helps on a day like that. So here's the actual patent drawing of the heat exchanger. You got ductwork here, getting that hot air from the highest point into the air to water heat exchanger here. You got your shrouds, fan, your motor, your panel, your case, your heat exchanger, breakdown of the fittings used. I don't think I had to use all that, but I did anyway. And a back plate access panel, so you could actually, change out that whole heater, this whole heat exchanger, if you ever had a leak or a problem with it. Got unions here to disconnect it from the tank piping, so that whole thing will just pop off. It's just, a drawing of it. All Microsoft Paint. Pretty awesome stuff. That's a breakdown of this would be the cooling, the one that sits on top of the drywall. Got a little notch in there. It's basically inverted of what radiant heat is. Just works opposite. So, but it's passive. That's the thing. Get your tube in there. Top view. Some more drawings. And these would be the hot water exchanger plates. Are kind of hard to see. These came out really. I think I was running out of ink on the printer here, but you got your flap that sticks up. Same basic deal, just with the flap. I don't know if you really need those. It's not really necessary. The interior of the roof gets so hot as it is. But these would be the cooling loops, just on the ceiling surface there. They'd be mounted to those studs. So, and I figured out how much pounds per square inch and everything. It's really minute if you just have the tubes. I didn't account for the exchanger plates, but those could be, if you could support them. If you put a strap across the top of them that hooked to that channel, somehow it would keep the weight off the drywall. I haven't had any problems with them though, with just the tubes. And this would be for a tankless, you got your bypass, three-way bypass here, either sending it up to your loops or directly into your tankless. Otherwise it would go up and return back, and you could actually use it as a preheater in this case too for your tankless. That way you could turn your tankless way down, use less BTUs in your tankless, save a little gas, because this water coming back out of the top system would be preheated to 110, whatever your attic is. So it would call for heat here. It would depend on the tankless heater you got too, how it would be arranged. But that's a preheater system for a tankless, or you could run it, you shut that valve, open that one into bypass the tankless, and it would come back directly into your hot water supply right there. So you wouldn't use any gas at all. Here's a patent application. Kind of blurry here. Kind of wrinkled on the top, but I think it's like 30 pages, mumbo jumbo, typed up. All the wording that you need and all kinds of crazy. You got, this is all prior art, which is inventions relating to this invention and how mine's, just setting up to show how mine's different from everything that else is out there. But there's tons of pages of that prior art stuff explaining water heating, and you got to do all that stuff. You got to make it stupid simple for these guys, otherwise they'll reject you. That's what I was told anyway, so I spent way too much time researching prior art. We got all kinds of patents here that are, could be used to say that mine's not original, but that's just, to reference it so I can show that mine's different. More patents, all relating to that stuff. Getting to summary. Yeah, I'm not going to go through all this in detail. You guys can research how a patent application is drawn up. It's a pain in the ass, but this is done to the book, at least to the book that I bought to do it. And I talked to, people that have patents and stuff. Just getting information. This has all been corrected by this guy, actually, that has a bunch of patents. Just getting my wording right and stuff. I'm trying to keep it easy for the guys so they can just flip through it and get the overall description. But this is describing by word with numbers corresponding to the drawings that show, how it goes start to finish. And there's different uses for this. I mean, You can use it as an emergency water supply if your power goes out, or if they cut off your water to your house. You could, you'd have X amount of gallons stored in your attic, just like you would in your water heater. Probably want to sanitize it first if it's been sitting up there a while, but otherwise you can, you got potable water, a bunch of it on tap there. Just close those valves. As long as your roof stays on, you're good. But yeah, this is a patent application. It's a whole bunch of pages, a whole bunch of time wasted, but at least I did it. I know how to do it now if I ever did get something that I knew I could make a bunch of money off of, but I think I could with this over here in Hawaii. So if any of you guys are interested, you want to build your own system, let me know. I could help you out with it. But yeah, here I'll get up in the attic and show you guys my prototype here. Alright guys, we're up here in the attic. This is a prototype, okay guys? I don't want to hear a bunch of comments about this and that. I mean, this is all stuff that I had on hand. I maybe bought a fitting or two where I needed one, but other than that, this is used or new, in stock, on hand, built in 3 days kind of stuff. Just getting a prototype going together to make sure it worked before I spent any more time on this stuff. I wish I had a thermometer to show you guys temperatures, because I mean, it does work, and I will get that eventually. Keep posted on that. You guys will see some temperatures out of this. But what we got here is just, we got, a structure built here to support the tank. And this is like a little 20-gallon electric water heater that I got off a job that we had a tsunami a while back, and this little tank was underneath their house, and it got swamped with salt water, and it fried all the electronics in it. And I could have changed all the electronics in it, but the case was inundated with salt water, so it would have started rusting. So I got that for free, and I took the case off of it just to get, so it's not sitting there rusting out. I know what condition it's in. I should have left it on there for insulation. I thought having the tank up here would be a bigger, it would draw more heat. It would suck more heat and put off more cold, more heat transfer, but what happens is at night it'll cool off. We want to keep that heat that we make, or not make, but store. So this is a little side view of it here. My batteries are going to die, so I'm going to cut in here and come back out. But what we got here is a 3/4 inch. This is Uponor Aquapex. That's the supply, and it goes into the bottom of the heat exchanger over there. Connects to the bottom of that heat exchanger. And inside here this is actually the case that was around the water heater, the sheet metal. And I just bent it up to make this box to enclose that heat exchanger. Again, this is just a prototype stuff that I had laying around the house. But cold water comes in to this heat exchanger and gets that fan on this side will actually suck heat and blow it through that forced air heat exchanger, and then the cooler air will come out here, transferring that hot air for cool air up here in the attic. You could pipe it in your house if you wanted to, but it's not really extra cool. It's just, a couple degrees cooler, but it puts that energy into the water, and over time it'll build up, and it'll start making some real heat out of that. But then the second, so that's also when it's static, there's gonna be no water, flowing besides natural processes. So the cold water is going to sink out of this tank. There's an outlet on this tank, and it's going to fall out of this tank. It's going to hit this, and there's a T right here that feeds the bottom of the heat exchanger manifold. And so it'll enter there, and it'll get hot, and as it heats, it'll rise. And then there's an outlet pipe that goes back into the tank at a little bit higher level than that cold water outlet, or that's an inlet, that's an outlet. So yeah, so it'll sit here and circulate through that, a couple degrees every once in a while, or, over a period of time. But over a period of a day, it's quite a bit. It'll exchange quite a bit of heat up here. And then that's one, and then the second part of it comes out of here. It drops out of the tank, comes along here. It's a 3/4 PEX Uponor, same stuff. A little bit out of focus, and I only have 2 loops. This is just a prototype again. And these 2 loops here on the ceiling, they just run right along the ceiling. They're all full of cold water when it's static, because thermodynamics will make it run, thermosiphon, and it goes all the way to the south side of the house. And then on the south side of the house, once again, homemade stuff here, folks. It rises up on this roof, and this roof temperature, if you feel the hurricane clips on there, I've tested them with a meat thermometer that I have, and I would show you guys, but it just recently broke. But they can get up to 135 degrees. That wood will get up to 120 all day long. And these pipes that are in contact with it, guess what? That water in there is getting up to that temperature too. And then it'll actually come back right there. This is the return, the hot water return, and that's those 2 same loops that you saw on the other side. And they just come up and they go into the top of the tank. So that in itself thermosiphons passively, no pump. It'll fall out of here, run along the ceiling, get hotter and hotter and hotter. And that, especially on this side, since it gets so hot over here, it's the capillary attraction will suck this cold water into there and make it hot, and it'll go into the tank and it'll sit there and circulate. So we got two passive systems working here on this puppy, circulating this water to equalize it with this attic temperature. Well, at the same time, it's making the water hotter, it's making the air in here cooler. This is the other side over here. There's the heat exchanger. I don't think you're going to be able to see in there, but it's just copper pipe with sheet copper soldered to it at, like, you know, real close together, as close as I could get it. It's just, you know, stuff I had laying around. I didn't buy anything for this. That's actually I think a 18-inch roll of roof flashing that I made into a circle here, and that puppy right there would be the bottom of like a planter, like one of your pots, your planter pots that I popped on there. It fit perfect in there. So, and then I just drilled a hole in it. I had a pipe rising up here, but I don't really have this thing supported too well. I need to do that. I'm scared about putting too much weight on here and having it break off one of these nipples, especially since they're galvanized. Again, used stuff that I had lying around, I just threw it together. But that's it. And this puppy, I mean, these pipes up here, I wish I had my meat thermometer so I could show you guys. I mean, it's not hot enough to where it'd burn you, but it's PEX, but it's to the point where, you know, you can feel that heat, like a lot of it. It's at least, I know I've tested this, the hottest temperature I got out of it was 117 degrees. And I'd get maybe, since it's 10 gallons or 20 gallons of water, that's a 10-minute shower at 117 degrees. And you don't, I mean, 117 degrees is too hot. So you're gonna mix it with some cold anyways. So really you're using, you know, you aren't using that much. But it'll start to cool off towards the end of it, just because the way it's piped and stuff. It's, you know, thrown together prototype, like I said. But it's a good system. If I had it full scale, I guarantee I could get this whole tank, I could get it up to 120 degrees, no problem. And then if you added a circulator to your supply and return downstairs, which I'll show you, you could pump this tank and exchange it for your storage tank down below. And throughout the day, you could fill that storage tank with water, plus this one. If it's all sizing though, on your loops and your heat exchanger, how many BTUs you're getting out of it. But it works. You know, usually I just have this thing running. I have it bypassed at my electric heater. I just turn that thing off and drain it and use this, because I don't need much hot water. I'm a bachelor, and unfortunately I don't shower every day. Nah, most times I do, but either way, I don't do the dishes that much. I only do a couple loads of laundry a week, so I don't need much hot water. But I mean, you could build this to any size. depending, you can't get too big. You may have to add an extra tank or, you know, stuff. You can't get too much more weight up in this attic. But me, I got it, the way I have it supported is, it's right over there's interior walls here, so these trusses are carried right where I have it. So it's not going to cause it to bow right there where all the majority of the weight is and stuff. And I got, you know, laying around the house, wrong size hangers and everything. But that works. I had to make this stand weird too, because since I took off the case, this bottom on this tank, it's not flat. So I had to make like a cup for it to sit into. So it's, you know, it's nice and solid. And I got it strapped up in there and stuff, so it's not going anywhere. Let me show you guys this one too, over here. Can't really see it. I got that one. That one's shady. It's just, you know, I forget what that's from, but I had it. Just trying to make a bigger surface area of heat to get to that pipe. And it's just, you know, wedged up in there. It's cheap, easy, fast. What I had just to see what the results would be. But this one over here is a lot better. That's probably how I do it mostly. Instead of running loops, I just run them straight up against those. And that's sheet copper that I recycled off a solar hot water collector, and I bent a channel in it for that to go in, and it just squeezes right up in that corner, and it really does. I mean, the temperature on the bottom, there's like a 10 degree temperature difference between the water entering the bottom and it leaving right there, and that's just passively, you know, going through there. The water, it's not a high flow, but it's enough throughout the day to accumulate quite a bit of hot water. Well, and at the same time, it rather than having all this heat radiating in here, it's sucking that heat out of that roof. So there's not as much heat actually penetrating the roof, which will actually overall cool off your house. So it's pretty cool, especially if it was, you know, if this was built to the dimensions on my patent. I bet you know, up here, it's 125 degrees before this thing gets full of water, and it gets down to 107, 110 when it's full of cold water. So if it was sized correctly, I'm sure it'd be a way, you know, it'd be a bigger temperature drop here in the attic and a greater gain in the tank. And that's how it works. All right, I'll show you the bottom here. All right, here's downstairs. The A.O. Smith 50-gallon electric, but all these pipes are all used stuff. I got this valve off a leaky backflow preventer. I had it in the scrap pile. All these heater flexes and stuff. I was just, you know, I wanted to hook it up so I could have ways to change it around and see what works best. But I'll show you how it works here. So you got your cold water is coming in here. Instead of going directly to the heater after you're shut off there, I just got it capped. It's actually a galvanized cap even. That's how I roll with this kind of stuff. I'd never do this to other people's stuff. I mean, I take pride in my work, but this is prototype, seeing if it works stuff. I did a nice job, you know, on this stuff here. But that's that 4-way bypass valve. When it's open like that, it allows flow through the valve on each side, but when you turn it off, it loops the top pipes together and then it loops the bottom pipes. So you got an inlet valve there to shut off the hot water. Either way, you shut that off, there's no water going any place. So that one goes up, get boiler drains on here to bleed the air, and it actually goes up just outside the wall and then goes into the attic right there. But coming back, comes down, and then I got just an elbow, and I put a T on here with a flex looping it to the hot side, and I got this valve here so I can shut that and open that, and it'll short circuit right to the cold side, and I can actually control the flow right here between these two valves and mix it so the water comes out of the tap at the perfect temperature how I want it. It's just, you know, used stuff that I threw in here. And these lines were actually off one of those hot water on demand pumps, but I didn't have to use them. They're laying around, so got to thinking about it and throwing stuff together. I had all this made up, you know, ready to hook up how I wanted it. When, you know, I was gonna solder it and make it all nice. I got a 3-way valve and stuff, but I just did it this way so I could see which way works best, and I got it pretty tuned in. But this how I have it right now is, it's a preheater for this electric tank. So instead of going into the tank right here, it goes into the attic and gets preheated by the attic system I just showed you, and it comes back hot, and then it'll come back and come into the cold water inlet on the hot water heater, or the water heater. There's no such thing as a hot water heater. Well, there is, but they're rare. You don't need to heat hot water most of the time. But in this case, it kind of works that way. And then your outlet out of your heater into your domestic right there. But good little system. I threw this one together for probably less than $100 with specialty valves and stuff. All the other stuff is just homemade. But that's it. Thanks for watching, guys. You guys got any questions? Leave them in the comments. I could help you build one of these, no problem. They're cheap, they work good. Especially if you're in, tropical area, somewhere that doesn't freeze. Even Alabama and stuff, you go up in your attics, it's hot. So, alright guys, aloha. Actually, I got this idea from Steve. He built one, or he buys his toilet syringe. I saw his, being the redneck innovator that I am. I made my own. It's a 1-inch PVC pipe plunger, and there's a cap on it inside here. It fits perfect inside the 1.5-inch pipe. And this is your plunger. It'll slide in and out. It's kind of dry right now. It needs to be lubed up, but good for sucking the water out of toilets and stuff, ditches, homemade kind. Alright, got my retirement building up over here. That's like a quarter of what I got. That's just the recent stuff. Alright, aloha.